So in this video, we're going to discuss a few common elements of our free body diagram. So a few elements that we will use commonly in engineering systems or in mechanical systems in general are springs, cables, and pulleys. So it's important that you understand how springs, cables, and pulleys work and some common assumptions we'll make when dealing with cables and pulleys and springs. So for a spring, for example, it's typically often drawn like this, where we have a force that's being applied to the end of our spring. So our force that's being applied can be either positive or it can be negative. A positive force or a negative force. A positive force is defined as a tensile force, which will cause the spring to elongate or get longer, while a negative force will cause the spring to compress and to shorten. Okay, so all right, so all springs operate under this condition where the force that's applied to the spring is proportional to its spring constant times the change in length of the spring. So we'll define we'll use S for that term, and then we can rewrite it as K times the current length of the spring minus the original length of the spring. So we have our spring constant. That's typically in units of newtons per meter or in pounds per foot. S is our change in length of the spring. Alright, L is the current length of the spring. And then LO is the original length of the spring, or the length of the spring when there's no external force being applied. All right. So using this relationship called Hooke's law, we can solve for if we know two out of any of the three variables, we can solve for the unknown force, or one of the unknown variables. So another common type of component are cables. So cables, we will assume that cables follow the following laws. That we will assume that all cables in this class we can say that they will have negligible weight. So we're going to pretend that the cables have no weight on them, all right, or the weight is insignificant. We'll assume that all the cables will not stretch. So they're not stretched out due to the forces that are being applied to the cables, and we'll assume that cables, which this is not really an assumption, this is just a fact, is that cables can only support tensile forces. Support tensile or pulling forces. So there's a common expression that says that you cannot push on a rope, and we're going to make that assumption. We're going to follow that saying in this course. All right. So often cables are used in just alongside with pulleys. So in this course, for a pulley, we're going to assume that regardless of the angle which the pulley makes with itself, we will assume that the force within the cable, which we'll often label as a tensile force, T, will be constant throughout the whole cable. All right. So, and that concludes this video on springs, cables, and pulleys.